Hi, this is Mrs. Slater, and today we're going to talk about determinants. So I first want to see if you can determine a couple of riddles. The first one is, what did the lawyer name his daughter?
Sue.
The second one is, what do you call cheese that is not yours?
Nacho cheese.
The third one is, did you hear about the kidnapping at school?
It's okay, he woke up.
And the last one is, what did the math student say to get a girl's phone number?
How do I know so many thousands of numbers, but not your 7-digit number?
Let's first start with determining what an actual determinant is. The rules for determinant is a matrix with the same number of rows and columns is called a square matrix. Secondly, with every square matrix, is associated a number called its determinant. And thirdly, the determinant, and that is going to be abbreviated as DET. You may have noticed that on the calculator under matrices already. The determinant of matrix A is symbolized like this. You'll have two bars on the side, and then the matrix will be inside. So you could have the 2 by 2 there, you could have the 3 by 3 inside where A is located. What you're going to need to know is how to define a determinant of a 2 by 2. So in the place for these variables, we have A, B, C, and D. Of that 2 by 2 matrix, those variables are standing for any number that could be there. That is going to equal A times D minus B times C. So whatever you get for the value, that's going to end up being your answer, and that answer is your determinant. So it will always come out to be one number. Now it might help when you start doing the practice problems is to actually circle them. You're always going to circle the top left-hand corner and the bottom right-hand corner, and then you're going to subtract the opposite diagonal. So keep that in mind on the next page. Okay, so the first example, I'm going to go ahead and circle where A and D would be located, and that would be 7 times negative 8. And then I'm going to subtract the next one, which is this diagonal, and that's going to be a negative 4 times negative 3. Now notice I put the negative, the negative as a red just to clarify. Make sure you are not forgetting that. That's the biggest mistake I think I've seen when determinants are being done. Okay, and then finally, let's go ahead and do order of operations, which is to multiply and multiply, so you get 12. And then when you subtract those, you end up with negative 68. So that would be the determinant of that original 2 by 2 matrix. Okay, so let's go ahead and try the next one. 5 times negative 3, we know, is a negative 15. Already I'm going to start with shortcuts. Minus, again, very important there, minus the other diagonal, which is 1 times negative 2, so that's a negative 2. And anytime I have two negatives, I'm going to make those positive. And for the final answer, it would be a negative 13. Go ahead and push pause and find out the next two answers. Okay, so hopefully you got a negative 24 for the first one. And for the second one, hopefully you got 0. Those are the determinant values. If you have any questions on those, I'll answer those tomorrow in class. You also can evaluate determinants when variables are present. For example, this first one, you are going to see the bars on the side, so that does mean determinant. That's how you're going to know. And then we're going to multiply the diagonals, so that would be 3x. And then the other diagonals would be minus x squared when you multiply those together. So at this point, that is all you can do. So we're going to have to leave our answer as an expression. Now in the next two, I'm going to change it up a little bit. If you could put equals 0 at the end of the determinant we're going to evaluate, just to put a little twist on this. And if we're going to find the value of x, we're going to have to do the determinant first. So if we're going to solve the determinant, it would be 4x, and again, minus, multiply the other two, we get 6, and then that determinant equals 0. And how do I solve? I need to get x by itself. So 4x equals 6, and then x ends up being 3/2 for that determinant. Okay, on the next one, the determinant is also 0, like I had mentioned before. And to define the determinant, let's go ahead and multiply the diagonals. That's a little tricky because x plus 4 is the whole number in that spot. So we would have, I'm going to write out a little more than I have been, x plus 4 times 2 minus, and then I have the other one, which is the x minus 1, and the 7, which is x minus 1 and 7. Okay, and after doing a little distributive property, I get 2x plus 8. And then after doing a little distributive property on this one, a little tricky with that minus sign, but I will leave it in parentheses just to make sure I did it right. It would be 2x plus 8 minus 7x plus 7. And then once you get 2x minus 7x, it's going to be a final answer of negative 5x plus 15, and oops, got the little equals 0. So I can go ahead and continue on and end up getting negative 5x equals negative 15. So therefore 3 will work if you plug that back into the original. Okay, so that would end up being 7, 7, and 3, so that'd be 2 and 2. And if you take 14 minus 14, you do end up with 0 for that determinant. So that's just a way to check your answer if you are unsure. Okay, so let's go on to a 3x3 matrix. So a 3x3 matrix would look something like this, where you have A, B, C on the top of the matrix, D, E, F, and G, H, I. So it's a 3x3 matrix, 3 rows by 3 columns. And then if you get your calculator out, go ahead and push pause because we're going to need that, and go into matrix. Okay, so now that you have that out, let's go ahead and put in the first 3x3 matrix. So second matrix, and if you go to edit, we are going to make a 3x3. So the first two things you're going to put in are 3 and 3, and then go ahead and push pause and do the rest. So once they're all in, double check, 3, 2, 2, negative 2, 1, 4, 4, negative 3, and 3 are in your menu, and then go ahead and push second quit. Okay, so once you're in your clear screen, now we can actually take what we need. And under matrix, math, so go in matrix and then go to math, you'll see the very first thing on the list is DET. Well, as I said before in the video, DET stands for determinant. So we're going to push enter, and then all we have to do is grab the matrix that we just made and place it into our clear menu. So it's already on A. I'm going to push enter and enter one more time for an answer of 93. So we would say that the determinant of this 3x3 is 93. Okay, so for tomorrow's class, we'll just go over the next two. Go ahead and find those out from the calculator, and we'll discuss those tomorrow. Hope you have a great day.